Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm down in Lake City, Florida, and I'm with Kurt Meer, and Kurt's with Meer Tool.
Meer Tool and Service.
Okay.
Yep.
And he has agreed to help us do some grinding on these wrist pins for the steam Stoker engine. I've actually worked with Kurt a couple times in the past. He's done some sharpening services for me. That's one of the things that you offer, is sharpening services. We're going to talk about that in just a little bit. But if you guys remember on our steam locomotive project we had a while back, I had to have some reamers custom ground with a specific taper in them, and Kurt basically took an off-the-shelf reamer and modified them and turned them into the ones we needed. So
took like a 1/4 inch per foot, made it an 1/8 inch per foot, right?
I think that's right. Yep.
Yeah.
Yep. And you got all the equipment there to do that. That's kind of what you specialize in. Real quick, briefly, just kind of tell them what you do here in your business.
Yeah, our main thing is sharpening services. We do saw blades, like carbide tip saw blades. The other part of my shop you'll see over here that is dedicated to that. And over here we call round tooling, like reamers, end mills, drills, countersinks, for both metalworking and woodworking industries. So it kind of grew out of helping different shops around town, and as they needed things, I added more equipment to service them, and so here I am today.
Yeah. I know I've sent you some involute cutters to sharpen for me and some other things. So great resource, and I'll tell you what, if you got cutters that you need worked on, are you open to doing that for the people? I mean, what?
Yeah, they can. You can go to my website.
Okay.
I got myerstool.com. That's spelled MYERSTOOL.com, and you'll find some information about me and the services I provide. But you can contact me from there with my email, and we can quote your products, or you can send stuff in and we can evaluate it and tell you if it's worth doing or not. So
good deal.
That's a good way to start from there.
Okay. Well, today we've got the wrist pins over here set up, and tell us about this machine we're going to be using to do this on.
All right. Well, this is a Cincinnati #2 tool grinder, and they made several different models. This is I call it a newer one because it has articulating head on it. It's made actually in England. They made these machines all over the world, different factories, and this one's made in England. And it can do cylindrical grinding, and I do a lot of bigger tools on this grinder. I've got some other KOLs that are smaller, but this is my bigger tool grinder for manual stuff. But we're setting up here to grind the tapers and the cylindrical part of this wrist pin, and we'll go from there.
Okay, good deal. I know when I had originally said, I thought we would do this on a CNC grinder, but when I reached out to Kurt, he's like, oh yeah, we can do this on my tool and cutter grinder. So I said, okay, works for me. So right now we're set up to do the taper. The taper is, what is it, 1.5 inches per foot?
Yeah.
That's the included taper. And so we've got this set up, and you basically just rotated the bed here.
Yep.
So that when you're going back and forth, we're actually cutting a taper. And we're going to do one side, and basically he's got an indicator set up on here as well as a dial on here, so that we'll have to kind of back off and go to the other side and go back into where we were to kind of finish that cut. But yeah, doable like it is.
Yeah, it should work good.
So let's get in here and we'll see this job getting done. So let's get her done.
Sounds good.
Thanks. All right, we are kind of just touching off here.
The spark off, yeah.
And it looks like it's hit it. I mean, he machined that on a CNC lathe, so the fact that you're kind of touching off pretty evenly there, or at least it appears to, looks like you probably got it pretty close on the taper.
Yeah.
Would be my guess. So anyway, he's just kind of touching off right now, and we're going to start cutting this thing, and you can kind of see down here, almost kind of shoots looking down, straight down. If you look, this whole thing here is offset, and that's the taper. The table still moves straight in and out, but it's on an angle here, so we're actually grinding a taper. And he actually has on there a scale over there in inches per foot that we were able to just dial into. So is it perfect? Probably not, but it's going to be pretty darn close. And you can see we're starting to touch off. I will note here that this part was machined on a CNC lathe, but it was not done between centers. The centers were actually put in this after the part was made, so there is just a little bit of run out. That's not because of the heat treating, that's not because of the machining, it's just the fact that we had to put the centers in after the fact, but we should have plenty of metal to take off to grind that little bit out. So anyway, he's starting to clean up one side, and we'll just kind of hit one side and then go hit the other side, and we're going to take them both to 0. Because that center section here, this was a straight taper, it would hit about halfway in there, so we're going to have to kind of do it. We're going to have to back off on the right side and come into using an indicator or the dials on the machine to kind of get it in the same plane, but again, doable.
I'm going to jump the other side.
All right.
Just to see how we're hitting.
You're just going to zero out your dial down here.
Yep.
All right. And then...
Wrong way. Let's get this one more. This machine is opposite of my KLA grinders on the forward direction and reverse direction on the straddle. So I have to think about it every time.
You know, it's aggravating. I've ran into that on other machines. In fact, I used to have a lathe in my shop. It was a LeBlanc lathe, great lathe.
Yeah.
But one of the controls on it was opposite of my Monarch lathe, and I actually decided to get rid of that LeBlanc lathe just because every time I get on it, I'm trying to do it backwards because I'm just used to doing it the other way. There wasn't anything wrong with the lathe.
Yeah,
it's just what you're used to.
Exactly.
And you know, you get to a point like, okay, you know, I gotta pick your battles. I would rather have another machine that I don't have to worry about. So
exactly.
we're clearing that. He's gonna come over here and then go back to 0 on this dial. And you're just adjusting a stop right now.
Yep, so to avoid running into the cylinder part.
Bring it in real slow until it touches off, and then you can take it back to 0 on the dial over there. There we go, starting to touch off.
Yeah.
And I just glanced down at the dial, it looked like you had about 7 thousandths.
Yep.
To get it to 0 from where it touched off. So.
Yeah, it's coming really.
Yeah, he's getting right on 0 there, so.
Real smooth action there.
All right.
So I've got a little chatter there. I'm going to dress the wheel and start from the other side again and get that area cleaned up.
Yeah, so right now what we're going to do is just get it cleaned up, and we're going to take it over and start test fitting it into the part it fits into and bluing it up and just making sure we got our taper just right.
I'm watching my sparks. I'm watching my wheel to see where I'm cutting. You can see on the part there's a little gray spot, and so I'm going to try to grind out.
You can kind of see that line going across there where you're grinding. I don't know if it shows up in the video or not.
Yeah, the leading edge of the grinding wheel kind of cuts a path. You can see the trailing edge cleaning it up. Because we don't know exactly how far this is going to fit into your part, I think I'm going to stop here.
I think that's probably good.
And jump the other side.
Yeah.
So set my stop at 0 again here, and back out the right direction this time. Just eyeballing the edge of the wheel so I don't hit the cylinder part. I got plenty of room on this side so I won't hit the threads.
I don't think you're going to hit the threads. I think you got enough clearance.
Yep. There we are, touch off. I'll bring this to 0 and then we'll go test it. That part just turned out pretty good. Actually, I kind of love that sound when it's full contact.
Yeah, it's making a nice grind.
Yep. I'm feeding in about 5/10 at a time.
About half a thou, yeah.
Yep, half a thou. Sometimes on bigger parts, I'll just tap it with my hand to get even less than that. I'm at 0 now.
All right, so now we're back at 0 where we'll on the other side, so we should be matching.
Yeah, pretty
just
close.
sparking it out, yeah.
Yeah. It's amazing how long you have to go to not get sparks anymore.
Yeah, and that makes a difference in your grind.
Yeah, you finish, you keep knocking off little mountains, and eventually you'll get a pretty smooth finish. We won't go too nuts with this. We'll go with that.
Oh yeah.
That's a nice finish.
Dressing that wheel made all the difference in the world on the finish there.
Yeah.
Good deal.
We'll glue it up, test it, and then hopefully we can get this ground out.
Yeah.
But that's even if that was left.
You still got plenty of contact with what we're doing, so yeah.
But we'll see how it looks.
Yep. All right. Let's take it and test it out. So we took a little blue ink. I actually just put a Sharpie pen on there and putting it in there and just kind of twisting it and looking where our areas of contact are. And you can see it's making contact down here, but this end on the other end in a couple places, but it's not quite there. And put it back in there.
Okay.
Because you can just kind of tell once it goes in that there's just a least little bit of play on this end. I mean, it's tiny.
You can feel, I don't know if you can see it, but I can feel it.
Yeah. And I apologize, it's kind of dark here, but you can feel it in there. So we need to increase that taper just a smidgen.
Just a smidgen, yeah.
Yeah. All right. So back to the machine, I guess.
Back to the grind.
Yeah, so we went and put this back on there and have just tweaked that taper ever so slightly, and we actually kind of blued this up with a marker and see, kind of turn it just a little, yeah, right there you go, and you can see the contact there. It's making pretty darn good contact all the way around, and if you put it into the crosshead there, no real vibration in there at all. Now it's tight. It's fitting really good. So I'm happy with that. Yeah, I think we're going to call the taper good on that one, and now that we got the machine dialed in, we can throw the other one up on there and get that taper done on it. Then we'll have to come back and do the straight.
Yep, sounds good.
All right, looks good.
All right, so we're on the second shaft. You can see a little run out. So we're slowly getting it worked out and grinding that away.
We were talking earlier, was the run out, was it from the centers or from the heat treat? And we think it's from the heat treat where it just kind of warped it a little bit, but that's not unusual with the heat treat. So we should have plenty of metal there. In fact, we've already taken this off and done a test fit. I think we're going to be fine. We've got plenty of metal to take off to get it to clean up, but coming along nice.
Yeah. The good thing he left 40 thousandths on there.
Yeah, we're going to need just about every bit of it on this one with that run out.
I know I'm not quite there, but I'm going to stop now and do a test fit.
Hey, you were commenting a while ago too about the hardness, and you were just talking about the sparks coming off of it, but you thought we were still in pretty hard metal,
Yeah,
right?
you can tell by the color of the sparks that we're still cutting hard. We're kind of reddish orange now. If I go soft metal, they'll be a lot brighter, like more yellow or even white.
Good deal. All right, we're going to do another test fit on this one. And you can see right there, it's still not quite cleaned up in one little spot, but we're making contact all around, even if that's just,
yeah, you see there.
If we have to stop there, it's not the end of the world, but I think we're going to be able to go a little bit deeper to get to the right depth. And just bringing it in.
That's tight.
Yeah, that's good.
Looking at our spacing here, we hardly want to go much more if we go at all.
Yeah, I'm probably with you. Let's just probably stop there. I mean, we've got a little bit of room over here on the front that we could come out before the bolt starts to hit.
Yep.
But when I look at get that in the camera frame, when you look at the slots, you know, we don't want to go much farther deeper in. So that's probably deep enough.
Yeah.
Let's just blue it up and just check it real quick, because we
Okay.
didn't put any blue on it. So I think that'll be good to do.
We'll do that.
So we're just taking a magic marker and just putting a little bit of, we're calling it bluing even though it's black. But
Yeah. A little ink on there.
put a little ink on there, and that way we can spin that in the part, and the contact areas will really tell us what kind of fit we got. So.
And we're hoping for a full contact all around.
Hey, I'd be happy with 50–60% contact all around, so anything more than that's just a bonus.
Yep. All right, let's try that. Give it a little spin.
Yep.
It's feeling
Lock it
tight.
in place. Yeah, that's fine. That's what we want.
So look at there.
Yeah. Do a full, just spin it around a
Okay.
full 360, just if you can.
Yeah, because it locks. I kind of
That's
want
the thing about tapers, is they lock, and so the fact that it's locking tells us we got that taper probably right on the money. So that's probably good. Yeah, so that's pretty good contact. I'm happy with that. So
yeah, we have a few spots where we have holes in our from the heat treat, but that's still going to work really good.
Yep. Like I said, if we got 50–60% contact, we're good. I think we're more than that, so I think we're way to go.
Yeah.
All right, so I think we're ready to reset the machine to cut the straight section.
Yep. We'll do that now.
All right, let's do it. What you're doing?
We are moving the machine back to 0 position from our taper, and I've got a little gauge here that tells me when I'm at 0. And then we're going to use a test bar and a dial indicator to fine tune it.
So that's reading in tapers in inches per foot. Does
Inches
it have
per foot.
degrees on it as well, or just?
Right here are the degrees.
Oh, okay. You got the degrees on over here. All right.
This one's just a taper per foot. So.
Oh, nice.
I'll get that set up at 0. Lock it in place, and then we're going to put a test bar in there and run an indicator across to see how it looks. You can see. Make sure my point's contacting. There's some movement there. So I'm high there. So I got to adjust that some more. A little tweak. We'll try that. You can see that or not, but
Actually, I can. Yeah, barely.
okay. Yeah, I'm going that way now.
Alright, we're touching off on the center section there, and what'd you say, about 25 thousandths to take off?
Yep, 25 thousandths, and we're getting, even though it's jumping, we're getting pretty consistent diameter reading across the whole face. So we're pretty close on our straightness. I think we're still dealing with heat treat warpage, but
yeah. And as I was telling him, the blueprint says 2 inches on that diameter there, but the truth is that we're going to have to bore the bronze bushings to make them fit 2 inches, because right now the original pins that were in there had worn down, I think about 25 thousandths smaller, if I remember right. So the bronze bushings that are in there were tight on the wrist pins, so they got to be bored out oversized. So the point is that if we have to take a little more than 25, I can bore the bearings to match, but we're going to shoot for the 2 inch because that's what the blueprint says.
That makes sense. A little at a time, we won't get it here.
Yep, let's take a little bite at a time. How much are you taking per pass?
I'm taking about 5/10, half a thousandths.
Okay.
So in reality, it's a thousandth on the diameter. I'm using a 60 grit wheel, and I've got it dressed pretty fine, but it seems to work pretty good. The balance is getting it dressed right, and so you have the right amount of fracturing going on to expose new grit. And this seems to be doing pretty good. Like I did the initial dress, and I haven't had to address it yet. And I can tell that it's not loading up too bad.
Good. Now, we were talking a couple minutes ago about coolant off camera. I mean, what's your thoughts on doing this dry versus under coolant?
Well, coolant is actually pretty good. I mean, it's going to be better, of course. Doing small parts like this, I have no problem doing them dry, especially if my wheel's dressed right. I'll get a nice, good finish. The problem I run with coolant, especially on vitrified wheels like this, they tend to load up a lot quicker. The wet grinding dust or swarf gets caught in the grains, and it wants to polish the metal pretty quickly. So I found doing them dry, I can go a lot quicker on small parts. That I'm not, as long as they're big like this, I'm not getting any heat buildup really per se. So it works out okay. Like this grinder here, you can see it's set up with a vacuum system, and with the right wheel, you can grind all day long and get good finishes. We're about to be done with the second part. This one was way better at concentricity, and we're right to our 0 mark. We're grinding these things 3/1000ths undersize, so Keith can have his proper oil clearance with his bushing, and that way he can run his bushing to right at 2 inches, and this is going to be the gap he needs. This is the final pass, and we're going to double check it with our mic right now. So, let's see where we're at. I'm at 2.5 under, so I got about 0.5 thousandths to go. Double check the other side. Yep. About 5/10.
You're just barely bumping that thing.
Barely bumping it, yeah. It's almost by feel versus sight at this point. One more bump and then we're gonna have it. It's cutting pretty clean right now. Our sparks are good. It's shatter free, so this will be a good surface finish. A couple more spark out passes and we'll have it. That's that. One more check with the mic. Now we're showing slightly under, but
it'll be fine.
Yeah,
we got plenty of tolerance in there.
Yeah, that's at 3. I'm gonna check that again over here. Yeah, perfect.
All right, that's good. So here we go. That's the last one in there, and that one is really nice. Having a good finish in there. These are ready to go back. I've still got to, once I get them back in my shop, cut this little work holding piece off the ends of these because those don't need to be there, but other than that, these are pretty much done. That turned out beautiful.
Yeah.
So Kurt, thank you very much.
You're welcome. Happy to do it.
Yeah, this has been fun.
Yeah, fun project to do.
All right. So before we get out of here, I think I'm going to just take a minute or two and just kind of walk around and kind of show you some of the stuff that Kurt can do here in his shop. Show you some of his capabilities, and
sounds good.
Yeah. So if you guys got any work they want to send him, I'm sure he'd love to work with you guys. So
you betcha.
Let's do a quick look at some of the stuff he does.
Okay. We do carbide tip saw blades. You see a stack here, right, waiting for replacement tips. We go through them, we clean them up, check for broken tips. You can see these are all chowdered out, and so we'll put new tips on them. And then you can see the tipping station over here, where we go through and desolder tips, put new tips on, and then we load the blades in machines like a face grinder here, and then behind us we've got a side grinder that grinds the kerf or the sides of the teeth, another grinder that does tops of teeth, and then we have a CNC grinder here that does basically tops and faces together. You can see it working.
Oh yeah, there's two
indexing between teeth.
In there, yeah.
Yep. That's pretty much saw blades. We do that all day, every day.
Wow.
Service mills and cabinet shops and whoever's cutting wood, or even sometimes metal with non-ferrous blades.
Yep.
Over here is what I call round tooling, like your end mills, drill bits, countersinks, reamers. You see a bank of tool and cutter grinders here. And we've got a CNC grinder here for doing specials and big batches.
So this is when you did the reamers on, right?
Yes.
Okay.
Yep. And then you can see the grinder here we just did the shafts on. And that's pretty much what we do, is do a lot of grinding work for tools and whatnot.
And you can do end mills, you can do reamers, you can do
drill bits.
Okay.
Back here we've got these cam-driven drill bit sharpening machines, and these are they're beasts. But we got plates for every drill size up to 1.5 inches.
Okay.
And this is an oil-cooled cam-driven machine that produces a factory-style point with split point.
Oh wow.
And so we get people who bring us buckets of drill bits, and we'll sort through them and resharpen them.
Cool.
But mainly, you know, big shops that use the same size over and over again.
Right.
I don't take on like a drill index with every size being a different one. At that point, you should buy new ones.
Right.
But and bigger sizes we'll do multiples of that, but that's what we do here. So
Cool.
yeah.
And again, if anybody wants to reach out to you or whatever, what's the best way?
Best way is go to www.myerstool.com, and that's spelled M-Y-E-R-S. And on there you'll find my contact information, and you can see what we do from the website and go from there. We'll be happy to quote you.
Awesome.
Yeah.
Well, Kurt, again, thank you so much.
Oh, you're welcome, Keith. I'm glad you reached out. It's a fun project.
Yeah, he's helped me out on some stuff in the past, and when this came up, I said, I'm going to see if this is something you can do. And my initial thought was, I knew you had that CNC grinder, and you ended up like, no, let's just do it old school way, which is even cooler.
It works good, yeah.
So anyway, I greatly appreciate it. This is a huge help, and again, if you got any special grinding jobs, he does a great job. He's done several jobs for me, and everything he's done has been awesome. So
I appreciate that, yeah.
All right.
Yeah.
All right, guys. Well, with that, we're going to sign off and get out of here. I'm going to head back home. I'm about an hour and 45 minutes away from the house, so I'm going to head that way and get back in shop, maybe get some work done this afternoon. So with that, we're going to sign off. We'll catch you guys in the next video. As always, thanks for watching. Please do subscribe if you haven't already. Those thumbs up and comments always also help out a lot. Big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. And with that, guys, we're going to get out of here. Start heading toward the house.
Sounds good.
Thank you, sir. Thanks again. We'll catch you guys in the next video.
All right.